All right, now let's talk about operations with our polynomials. So, basic operations, add, subtract, multiply, divide, that's what we're talking about here. Whenever we're adding or subtracting, all we're doing is combining like terms. If they're not like terms, you can't do a dang thing with them. Now, when you are subtracting, I'd highly advise first distributing the negative. So let's just look and see what we're doing here. We're adding. Okay, so if we're adding, there's really no need for these parentheses. You can ignore them entirely. It's just a grouping symbol. Combine your like terms. I got some x squareds there. I got some x squareds there. I got some x's here. I got some x's there. And I got a constant here. I got a constant there. Make sure you write these in standard form. So that is descending order. All right, so 3x squared plus x squared is 4x squared. 11x minus 5x is 6x. 4 minus 13 is negative 9. That's it. You cannot do it. Anything else. That's it. You have x squareds and x's. Those are not like terms. You can't do anything with them. Don't try. That's it. Just put it in order and you're done. Let's check this next one out. We got some cubes, and no cubes over here. Got some n squareds, got some n squareds over here. We got an n, we got an n over there. We got a constant, we got a constant over here. Okay, so 9n cubed. Didn't do a thing to it, not gonna do a thing to it. And of course we are still adding these, so we can pretty much just pretend the parentheses are not even there. A negative 4n squared and a negative 2n squared makes a negative 6n squared. Feel free to use a calculator, and I apologize if I screw up any arithmetic. 2n plus n is 3n. Negative 10 and a positive 7 makes a negative 3. We're in descending order. These are all different terms. We have n cubes, n squareds, n's, and a constant. So yeah, they're all different. Can't do anything with them. Done. Now, you're subtracting. Depending on how fluent you are with things, you could, say 5k cubed minus, no k cubed, so it's just 5k cubed. Negative 2k squared minus 2k squared, negative 4k squared. You could. I'd suggest attributing a negative first. Just do it. Take an extra step, especially if you're one of those overconfident people that keep messing up simple mistakes. Distribute the dang negative first. So I'm going to just copy this down. There's nothing out here. I don't need this parentheses set. It's just grouping symbols, and we don't need it grouped. So I'm just going to drop it. No need. There's nothing being multiplied to it. There's nothing being done to it, actually. So it's just indicating, oh, hey, pay attention. I'm this polynomial minus that polynomial. But we really don't care because we're looking at each monomial. Negative 2k squared. Negative 2k. Negative 17. There we go. Now we combine all our terms and put it in standard form, descending order. So let's see, I got my k cubes, I got some k squareds, I got some k's, and I got a constant. Okay, that's it. For you, not doing a thing to you. Negative 2 of them and negative 2 of them makes negative 4 of them. 4 of them, k squareds. 2k and negative 2k makes a no k. Okay. Hey, okay, yeah, 0k, but we don't put 0k. We just leave it alone. It's canceled, it's gone. Bye. Minus 17. Done. In descending order, nothing is like terms. We're good to go. Again, these parentheses don't mean anything really. This negative needs to be distributed. Whether you do it in your head or on a step is up to you. Unless you're extremely fluent, I would suggest actually writing it out. Y plus 4y squared minus 3 negative and 1 is negative 1. Negative and 2y squared is negative 2y squared. Negative and negative 5y makes a positive 5y. We're multiplying here. Negative and negative y cubed makes a positive y cubed. So let's see. Let me see. Ooh, okay, so my biggest thing is a y cubed. I got a y cubed there. And I got some y squareds there. I got a y, another y. And I got some constants over here. I'm just making different marks so it's easier for me to find them whenever I'm trying to combine like terms. Now you could just combine like terms and then put it in descending order. If you got to, you got to. It's up to you. But I'm looking, I got y cubed. That's what I'm going to start with. Boom. Didn't do anything with it. There's no other y cubes. I got 4y squared and I got negative 2y squared. That can be 2y squared. I've got a y and a 5y makes a 6y. I got a negative 3 and a negative 1 makes a negative 4. All you're doing is combining like terms. That is it. That's how you add and subtract polynomials. All you have to do is combine your like terms. That's all there is to it. Okay, that's adding and subtract. Let's look at multiplying. Distributive property. That's it. A lot of distributive property. I'm not going to do all these because it's just going to, there's no point. You know how to use the distributive property. We're just going to do it. So here's a binomial times a trinomial. It doesn't matter what it is. Every time you're multiplying, you're just going to use the distributive property. How do I know I'm multiplying here? Well, I've got this thing right next to this thing. And whenever you have two things next to each other, it's understood multiplication there. They're in a set of parentheses. Parentheses next to each other means multiply. So let's just do it. Now, for those of you that haven't paid attention to my class, there's that F word that you can use with two binomials like this. That's two binomials. You can use that F word. You don't use that F word in my classroom. It's a distributive property, period. So the distributive property, everybody on the left side gets multiplied to everybody on the right side. Easy as that. So W gets multiplied to everybody, negative 7 gets multiplied to everybody. Find something else, it would get multiplied to everybody. Let's do it. So you can know how many terms you're going to have because I got 2 here, 3 here, that's 6 terms I better have. If I don't have 6 terms, I miss something. 2 times 3 is 6. W times W squared is W to the third. Power rule, 1 plus 2 is 3. W times 2W is 2W squared. And a W times a 1 is a W. Negative 7 times W squared is negative 7W squared. Negative 7 times positive 2W, negative 14W. Negative 7 times 1 is negative 7. Again, just organize yourself. I've got some W cubes. I've got some W squareds. Got some W's. And I got this guy all by himself. That's everybody, so put them together. Biggest term, cubed. That's the highest degree. That's what I'm going to start with. W cubed. Do I have any squareds? Yes, I do. I've got 2 minus 7 is negative 5 W squareds. W and negative 14W makes negative 13W. If you are using a calculator, don't try and put the variables in there. Just use the coefficients. So you do 2 minus 14, not 2W, or you do 1 minus 14, not W minus 14W. It is completely different. Don't put the variables in your calculator, please, for the love of anything. That's it. Nothing else to combine. We multiplied it all out. Done. Skipping number 7. Let's look at one more interesting. Let's see. I'm going to do number 8, and I'm going to show you what to do on number 9. I mean, it's It's all the same process, just the distributive property, people. So I got a constant. I like to leave those for last. That's just me. What I do is I pick two terms, the bigger the better. I got a binomial, 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 and a constant out here. You could just distribute the 3 right now and then do that and that. Makes bigger numbers to work with. I like to just do it all at the end. Personal preference though. Pick 2. Go 2 at a time. You can't do it all at once. You can't. So I'm gonna multiply these 2 together. So I'm gonna copy everything else down. And I like to stick it in a big old set of brackets because that'll help me remember that I've still got other junk out here. A times a squared. A times -2, -2a. 5 times a, 5a. 5 times -2, -10. Close that bracket. And so that's this thing. That's what we just did this. Copy this down. Now you're welcome to leave this and write the whole next step, combine like terms. I'll copy and paste it, I guess. But personally, what I would usually do, instead of writing out the whole step again, and instead of -2 and 5, that makes positive 3a. What I'd usually do is I just scratch that out and put 3a. And then I'd use the sugar property again. I'd probably put the positive just so I'd emphasize a squared plus 3a minus 10. But if you need to write another step, do it. Again, it depends entirely on how comfortable you are with these. It is just the distributive property, which you've been doing for 5 years now. 6 even. So you could distribute the -3 now, but again, I like to save that for last. I like to do all my binomials or trinomials or whatever kind of polynomials I have first and my constant last. Here we go. This thing times that thing. That's what I'm doing now. Remember, brackets are just like a big old parenthesis. Same exact thing. It's a grouping symbol. Copy down the -3 because I haven't used it yet. A squared times a cubed. A squared times 8, 8a squared. 3a times a, 3a squared. 3a times 8, 24a. -10 times a, -10a. -10 times 8, -80. Close my bracket. Combine like terms. Then distribute the -3. Okay. So what do I have for like terms? Let's see. A cubed, that's only one of those. A squared and a squareds, a's and a constant a right here. Negative. Let's see. 3 times, you know what? Yeah, I'm gonna do it. A cubed, 8a and 3a makes 11a squared. All right, that's a squared the first time. 24 and a -10 makes a 14a. And then -8. Finally, distribute this -3 to everybody. I'm already in, descending order, so all I have to do is multiply by that -3, and I'm done. Things combined, nice, neat, ordered. Just multiply by -3, and we're good to go. Okay, just multiply by -3 times all your coefficients. And do feel free to use a calculator. But that's done. Finished. The end. Next problem. So again, I said I'd show you how to do this. I wouldn't do it because it's a exact same process every single time. What does cubed mean though? Thing times thing times thing. It's multiplied by itself. You've got 3 of them. So you write it out. Write it out. Don't try and do it in your head. Write it out. Every time. Doesn't matter if it's a squared, a cubed, a fifth. I don't care. Write it out. Unless, of course, you have a monomial. Then we talked about that last lesson. You don't need them all. Write out the monomials. If it's a binomial, trinomial, or any other polynomial, write it out. Oof. Cubing a trinomial would not be fun. Anyway. So you just, do these two together, just like we did here. Take the first two, or any two, really. Multiply those, combine like terms, distribute the property. Multiply those, combine like terms, distribute the property again. I'm not going to do it. A trinomial times a trinomial. We haven't done one of those. We might. Let's see what's next. Yep, division. Okay, we'll do this. We'll do this. Okay, yep, we're going to do this. We can do it. So you're going to multiply everybody in here times everybody in there. I got 3 in here. I got 3 in there. 3 times 3 is 9. So I better have 9 terms at the end of this thing. So I'm going to start way over here. X squared times negative x squared is negative x to the 4th. Give me just a second, guys. Okay, I'm back. So, where are we? Yeah. X squared times negative x squared, negative x to the 4th. X squared times negative 9x, negative 9x cubed. X squared times negative 4, negative 4x squared. That's it for this guy. Moving on to the next one. Positive 6x times a negative x squared is negative 6x cubed. Positive 6x times a negative 9x, negative 54x squared. Positive 6x times a negative 4 is negative 24x. Done with this guy. Negative 7 times negative x squared is positive 7x squared. Negative 7, negative 9x, positive 63x. Negative 7, negative 4, positive 28. 1, 2, 3, 4, 5, 6, 7, 8, 9. Got 9 terms, so I have the right number of terms. Doesn't guarantee I'm right, but if I don't have 9 terms, I know I'm wrong. Hopefully we're okay. I know I only got one of those, and I only got one of those, so I'm not going to worry about that. But I got some cubes here and here. Squareds here, here, and here. Oh, I didn't put the x on this. Sorry. So this is negative 7 times negative 9x. I left off the x. Sorry about that. And I got regular old x's here and here. Descending order. So I'm going to start with the negative x to the 4th. Then I'm going to go to the x cubes. I've got negative 9 and negative 6 makes negative 15 x cubed. Then I'm going to go to the x squareds. Negative 4, negative 54, that's negative 58. And a positive 7 is negative 51 x squared. X is next. 24 and 63, a negative 24 and 63, that's what, 39, I think. All right, let me just pull up the calculator. Let's be safe here. I don't know. There, there, there. Okay. Where are we? 63 minus 24. I'm pretty sure I didn't screw up, but let's just make sure. Okay, 39. We're good. And then we got that plus 28. And that's it. No more like terms. It's in descending order. We're good. So that's multiplication, guys. It's just a bunch of freaking distributive property repeatedly and over again and combining like terms and distributive property. There's this one we didn't do. Let's just talk about it for a second. So this one we have the distributive property here, the distributive property here, and then we combine like terms a couple times. This is not new to you people. This is not new. Now, this quotient might be a little unfamiliar to you if you don't. You should have. But let's not assume you did. So let's just do it. We're strictly dividing by a monomial right now. Polynomial division is a whole thing on its own. We'll get there eventually. Right now, we're going to only divide by monomials. If there's anything down here other than a monomial, don't worry about it right now. We're not doing it. Later. For now, we're dividing a polynomial by a monomial. Stay with me. Polynomial divided by a monomial. Okay? To do that, since we have a single monomial down here, we can split this up. And I'd highly advise doing it. We got 9m cubed over 3m minus 24m squared over 3m. Again, let me reiterate. Only for dividing by a monomial. This is the only time, this is the only way you would do it this way. Polynomial divided by anything other than a monomial. Not yet. So then you could, separate these if you needed to. It's already kind of separated for us. So I'm not going to erase. It's confusing. 9 divided by 3 is 3. M cubed divided by m is m squared. If you don't know how to do that, go back to the previous lesson. It's going to be a negative. 24 divided by 3 is 8. M squared divided by m is m. Are these like terms? No. Are we done? Yes. We got 3 of them over here. So if you look at your numerator and you have like terms, go ahead and combine like terms before you divide. Just makes things a little bit easier. In my opinion, anyway. Split it up. It's a monomial on the bottom. Split it up. Everything over that divisor. So 4 there. So everything divided by 4x. Just this divided by 4x, this divided by 4x, and this divided by 4x. Each individual term up here, we have a trinomial. Take each individual monomial and divide it by the divisor. That is a monomial. And you simplify. 5x squared, negative, that's a 1. That's an x. So negative x, I'm not going to write the 1. Negative 2. The x's cancel. What's 1? It's x over x, right? X to first over x to first. 1 minus 1 is 0. Anything to 0 power is 1. Or just remember, anything divided by itself cancels out, basically. It's gone. It's going to be a 1. So we just have 8 divided by 4 times 1, which is just 8 divided by 4, which is 2. What's the next? Descending order, no more like terms, moving on. Okay, let's see. Okay, we'll just do them all. Why not? If you're already good, we'll go do it. This one looks a little different. Notice that we have this negative exponent. Technically, you could use this as a multiplication thing, turn that into a half. A to the negative 1, b to the negative 1, and then just multiply it all out, blah, 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 distributive property. It'll work. I would find it personally easier if I just considered this as my denominator. So if you need to, rewrite it as a fraction. It's going to be this thing over that thing. So take a shortcut. If you're comfortable with it, you can do that and just stretch that out. If you're not comfortable with it, write it out again. Now, all of these are going to be over 2ab because we're just reciprocating this, right? This is going in the denominator. So all of this is over 2ab. Now, I'm not a fan of writing, so I am going to take a shortcut here. I'm going to go ahead and split it up. If you need to write a whole other step, write a whole other step. It depends entirely on you as to what you need. 14 divided by 2, so we are grouped. So we got the numbers together, we got the A's together, we got the B's together. I don't need to put the lines there. If you need to, put them. If you don't, don't. That's 7a cubed b squared minus 10ab plus, they all cancel, so that's a 0, right? So plus nothing, so I just, they cancel what? It's going to be 2 to the 0 power, a to the 0 power, b to the 0 power, which is 1 times 1 times 1, which is 1. Yes, I said that really fast. It's 1. You can think of it as something divided by itself. It is 1. No more like terms are done. Go on. So this thing, I mean, it's more the same. It's no different. Is there anything interesting in this one? There really isn't. Well, the 6 over 12, that'd be a half. It'd be 2 in the denominator. Maybe. What's the next one? We might come back to that. Probably not. This is more interesting. Let's do this one. So again, it's already in the nice division bar, so we're basically going to split this up. So if you really want to be lazy, you could kind of do this, this, and this, this, or you can write it a whole nother step. I don't care. Whatever you need to do. But I do need to see somewhat. Like, you can't just write the answer down. That's not going to be accepted. It's not which thing you type it in. Photomath, my math out, Wolfram, whatever. Show me some. That's 10x. 30 divided by 3 is 10. X cubed divided by x squared is x. Minus 12 divided by 3 is 4. X squared divided by x squared is 1. So it's just 4. Plus 9 divided by 3 is 3. X over x squared. Where's the bigger thing? X squared has a higher exponent. It's in the denominator. So I'm going to have my x in the denominator, and it's going to be 2 minus 1 is 1. So just x. Oh, hey, I'm done. Okay. Interesting. This is not a polynomial function. We have x's in the bottom, technically no longer a polynomial function. It's not how we're going to. Whenever we go to graph these things, you won't have any x's in the denominators. Those are rational functions. We'll talk about those a whole other time. Interesting. That's what I wanted to see here. So whenever we say polynomials, we're just talking about the general multiple monomials stuck together, not necessarily whenever we go to graph a polynomial. Because you know the polynomials have those nice little curvy looking things. This doesn't. This is a rational function, but it was a polynomial divided by a monomial. So it's operations with polynomials. Doesn't necessarily produce a polynomial. Just understand that. Yes, it has multiple terms, but it's not classified as a polynomial because this exponent is less than 0. You can have an exponent of 0. You can't have an exponent of negatives or fractions. That's square roots and stuff. Cube roots. Can't have those either for a polynomial. Anyway, off topic. Back to the topic. It's dividing those things. So I'll write this one out. Why not? So just separate your two terms up here. 40 divided by 8, 5. M cubed divided by n, m cubed divided by m squared is m. Oh, look at this. Bigger in the denominator, going in the denominator. Into the first pile. 5 minus 4 is 1. 3. No more m's. N squared. Done. That's it. And whenever we're talking about polynomials, the functions, the graphs, we'll only have one variable. We're only talking about single variable polynomials when we're graphing. Who cares? Later. That's later. That's it. I do believe. Yeah, very good. I mean, this is just more separated. You'll have 6/12, which is a half in the bottom. Nothing else really interesting there. Yeah, you should be good to go. Do your homework. Goodbye.